Okay, this is lesson 4.4, modeling with formulas. So we've been talking about algebra, that's just arithmetic with letters or with variables. And we've been learning all sorts of things we can do with them, such as the distributive property or multiplying with fractions and dividing with fractions and all that good stuff in order to solve equations. Now, there are special kinds of equations called formulas or formula. And a formula describes
an algebraic relationship between two or more variables.
Oh, how'd you guess?
An algebraic relationship between two or more variables. Can you give me an example of a formula?
A equals pi r squared.
So in the case of a circle, the area of a circle is pi r squared. What about the circumference of a circle?
R d2r.
R d2.
No, R squared. R times 2. R squared d. 2 pi r
I think this is just
squared. Pi.
yeah
pi
diameter.
R.
Yeah, 2
R.
pi r.
Oh, we don't have that one.
Okay.
Oh.
So anyways, these are examples of formulas. It relates, so the relationship, between two or more variables. Here we're relating the circumference of a circle with its radius. If the radius grows, the circumference will grow. If the radius is smaller, the circumference will be less. Okay? The relationship between the variables, it's defined by c equals 2 pi r. So whatever r is, you multiply it by 2 pi and you'll get c. Okay? What we're talking about today is how can we rearrange formulas. So it's not super challenging. You just need to slow down and take a look at what's happening. We're given this property of a triangle in example 1. It says in geometry, an exterior angle of a triangle, so in this case D is the exterior angle of the triangle, is equal to the sum of the opposite interior angles, A plus B. Okay? Is that part making sense so far?
Yeah.
Okay, this property makes sense because, let's say we named this x. Well, 180 minus x leaves these two, because we know the sum of interior angles is 180. And because these guys are supplementary angles, 180 minus x also leaves d. So d is 180 minus x, and a plus b is 180 minus x. So d and a plus b must be the exact same thing. They're equal.
Sir.
Okay, so that's where that property comes
Why would
from.
you minus it?
All right, our goal is to rearrange this formula to express a in terms of d and b. So right now we have d isolated on the left. You can see that?
Like it's in
Our goal is to have a isolated.
Why?
But right now
Why
a
do you
is
decide
attached to b.
A's don't want to
Okay, so we're just learning how to rearrange formulas. So look, if I write what I have in our scale, we've got d on one side, and we have a plus b on the other side. So how am I going to get a by itself, Jaden?
Do d minus b equals a.
Okay, good. Let's go a step back. I asked, how am I going to get a by itself? Well, I have to subtract b from this side. If I only subtract b from this side, guess what's going to happen? This side's going to be heavier. It's going to go down. It's going to be off balance. So if I do something to the right, I have to do it to the left. Look at how that works here. I'm subtracting b from this side, so I have to subtract b from this side, which on the right leaves me with just a, and on the left I now have d minus b. I haven't changed the values of a, d, or b. I haven't even tipped the scale of the equation, not even a little bit. The equation is still perfectly true because I did the same thing to both sides. But now, look, I have now expressed a in terms of d and b. This is the relationship of a, d, and b when I'm trying to find a. This is the relationship of a, b, and d when you want to find d. We didn't change anything. We just said, okay, what if we know d, but we don't know a? Oh, then I could use this formula. and it'll get the exact same answer. Okay? It's just learning how to rearrange formulas. Okay, in B, we have another example to do. The circumference of a circle, which we wrote up here, in terms of its radius, is given by c equals 2 pi r. Guys, that in terms of is really important vocabulary. This shows c in terms of r. Okay? These guys here, 2 pi, that's just a number. This is just a number. Okay? 2 times pi is just a number. Okay? It's an irrational number, but it's still just a number.
You divide it.
So basically it says to get c, you can take r and multiply it by 2 pi. But what we need to do is rearrange in order to isolate r. So we're saying, what is happening to r here? Right now, r is being multiplied by 2 pi. And I'd really like to get r by itself.
So minus
Oh, you
R
divide
from
it?
C.
No.
You like 2.
You do C divided by 2
Oh,
equals
3.
R.
There's
Slow down. Just slow down.
2 times.
Okay? Look, they're attached by multiplication. So just like this, look, if I had 4x and I wanted to get x by itself, what would I do? I'd divide by 4. Oh, okay, and I'd get just x. So over here, if I want r by itself, I have to divide by 2 pi.
Alright. But you have to do
And
that
if-
to C.
Thank you. I also have to do the same thing to the other side, or my scale will tip,
And then,
which gives you over here, this all crosses out. Pi over pi is 1. 2 over 2 is 1. So I just have r equals c over 2 pi.
great.
And I would rewrite that so that my variable that I'm interested in is on the left. R equals c over 2 pi. So now, if you know the circumference, you're like, oh, I can draw a circle. Maybe I have this much rope to map a circle. Okay, I'm going to do rope around. How big should the radius be? Well, now you can figure that out using this formula. Whereas it would have been a little bit more difficult using the original formula. Could have done it, would have got the same answer, but now you can rearrange and use this one.
Are we actually going to
Okay.
be using machine?
So this is all just to learn how to isolate a letter?
You got it. That is exactly what we're doing.
America.
C, the area of a square. This one's a little more challenging, okay? This is where we quit yesterday. The area of a square is related to its side length, right? We know area of a rectangle is length times width, right? But in a square, length and width are the same. They're both L because they're the same length. So in a square, the area is not length times width, it's length times length, which is length squared. Okay, so that's the original formula that we're working with. This formula expresses area, who can finish that, in terms of length. Okay, area in terms of length. Now how can I rearrange this in order to express length in terms of area?
Why would we want to? Then you just flip them.
No, square root.
32 square rooted.
Why don't you just
Good.
take apart the
So-
two?
There's two different ways. Basically your problem.
Wait, where
So example C gives us our formula, A equals L squared. But it also says that we have a goal to find the length of a specific square. The length of the sides of a specific square. It gives us a square, and it says that the area is 32 meters. Nope, centimeters squared. So that's the area. That's the number of squares taken up by this thing. Okay? So we can do it two ways. One way to do it is to substitute in your value for A, which is right here, and then solve. So method one, it's sub in the value and then solve, and it looks like this. We have A equals L squared. We know that A is 32. So 32 equals L squared. Well, we don't really care what L squared is. We want to know what the length of one side is. We want to know just L. So what am I going to do to get L by itself? Well, yeah, I have to do the opposite operation here. So L squared, in order to undo that, I'm going to square root the right side. If I square root the right side, have to square root the left side. On the right side, the square root of L squared is just L, right? We're undoing the squared, so obviously we're going to be left with just what's inside there. And square root of 32, you can do on your
I
calculator.
don't know what the square
5,
root is.
6,
Oh,
8,
just kidding.
5, 4, 2, 4, 9.
5.66 approximately?
Yeah.
Okay.
What's this little dot for?
So,
That means approximately. That means it's not exactly 5.66. It's 5.6, yada, 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 yada. Okay, method 2. In method 2, we're not going to sub in our value for a first. Instead, we're going to rearrange our formula first. And we do the exact same steps. In order to undo this squared, L squared, I'm going to take the square root of both sides. Now I know that the square root of a is L. So now I can substitute in my value for a. Make sure it's under the square root sign, right? A is under the radical. And we get the same answer. L is approximately 5.66.
can you just wait? How did you?
So if you're given A, you can find L. If you're given L, you can find A. You can rearrange and then substitute, or you can substitute and then rearrange. It makes no difference which way you do it.
Square root it.
Example 2, they give us a little bit more of a challenging formula, and we're going to rearrange it in 2 steps. So you might not know this already at this point in your math education, but this is called, let's say, a coordinate plane. I don't know if you've heard that. It's got an x-axis and a y-axis, coordinate plane, and this is called a
Axis.
line. Good.
Wow.
That's called a line. Now, the equation of a line is in this form. Y equals mx plus b. Okay? In this equation, m is the slope of the line, and b shows where it crosses the y-axis. You don't need to remember all this. I'm just giving you some basic introductory knowledge. These guys, m and b, they're just numbers. Okay? They're just numbers. So, for instance, this line looks approximately like y equals, I'll call it, well, to make it easy, I'll call it 1x minus 2. Let's say it crosses here at negative 2. Doesn't matter if you know what I'm talking about at all. All I'm showing you is that, look, now it's an equation, and it has 2 variables in it, and it shows how y relates to x. So this shows what the value of y is in terms of x. So if I knew what x was, I could find y. Right? If x is 1, I'll know what y is. Where x is 2, I can figure out what y is there. Where x is 5, I can figure out what y is there. Where x is 7, I can figure out what y is there. Okay? Doesn't matter if you know all of this ins and outs. We get into that a little bit later in the course. But for now, you need to know that an equation of a line relates the x and the y values that are on the line. Okay? Again, doesn't matter if you know it a lot. But we're going to take this formula for a line, y equals mx plus b, and we're going to... Our goal is to rearrange this guy, and the question says, the equation of a line relates y to x, m, and b. Okay? 4 variables in one equation. Rearrange this equation to express x in terms of y, m, and b. So which variable do we want to get by itself?
X.
Okay, we want to get x by itself. We already know it's going to take us 2 steps. And when we are solving equations, so we're not evaluating, we're solving, remember that we use BEDMAS? How?
Backward.
In reverse, okay?
A
So
sandbag.
the first thing that we're going to do in order to strip stuff away from x, we can kind of see he's really glued tight to this m by multiplication.
Yeah, they need to be broken.
So, but we need to start down here. Is there anything I can subtract or add from x?
Or B.
B is attached by addition, so I can detach it by subtraction. So here we go. I subtract b from the right, which means I have to.
Subtract B from the left.
All right, now rewrite your next step. We've got y minus b and we have mx.
Divide M.
Now we can divide the right side by m. And if I do that to the right side,
You
look,
must do it to the left.
the whole thing.
I don't like
So
that.
now y minus b becomes a group, and it's the whole y minus b is being divided by m.
So Y
This
minus
is where I would not know.
So y minus b over m, that's as simplified as that's going to get right now. And over here, our m's cross out, and we're left with x. So now we've expressed x in terms of y, b, and m.
That's good.
Okay?
Seems like you're just like literally.
Ladies and gents, your practice problems for lesson 4.4 are on the bottom of page 12. They are from page 253, numbers 1 through 12. Thank you, and have a good day.
Oh,